Hello, and welcome to today's Automotive Electronics Roundtable compilation. Global Spec and Mobility Solutions leader Murata recently brought together industry leaders, engineers, and innovators for a series of roundtable panel discussions on the essential technologies disrupting the traditional automotive market. Highlights of those discussions are now available in this compilation, which looks at the current state of Advanced Driver Assistance Systems, ADAS, what's available today, what can be expected in the future, and how the transition from now to tomorrow is likely to unfold. In this one-hour compilation, a wide-ranging group of experts will touch upon the challenges, including technical roadblocks and safety concerns. They will also discuss the various forces enabling the rollout of the e-automobile, including the role that governments will play and the business opportunities inherent in the changing automotive landscape. And they'll even have some fun along the way through anecdotes and observations from lives spent on the front lines of the autonomous driving revolution. Murata is proud to sponsor this presentation as part of its contribution to the future of mobility, which also includes the development of high-performance sensors enabling accurate vehicle positioning, maximizing cruising distances, and expanding the robotic ability to detect surrounding obstacles. The future of mobility relies on technology. That technology relies on Murata.
We're going to talk today about level 2 plus and 3 ADAS. So let's first talk about the differences. What are the differences between those two levels?
Again, I'll take that one.
Thank you.
Okay, so I think the best thing is to always revert back to what the standard definition is that's widely accepted on the 6 levels of automated driving, which is the SAE definition. And if you look at level 2 functionality is the vehicle can brake and steer, but only assist the driver. The driver is in full control all the time. An example of that is lane keeping or adaptive cruise control. Level 3 is very similar, but under very specific conditions, the vehicle can in actual fact drive itself. But the driver needs to remain engaged with the vehicle and ready to take over if the conditions change and the functionality moves outside of the vehicle's scope of operation. And an example of that would be the traffic jam chauffeur.
Now, is that already considered autonomous driving, or we are still far from consider level 3 autonomous driving?
I think if we look at, and unfortunately, I think Tesla is always a case that's always going to be studied. By virtue of the fact that there are so many videos posted on YouTube of people falling asleep and being driven home by the car, and people just not driving the car and the Tesla driving itself. So I think in most cases, a vehicle like the Tesla at this point in time, now ignoring the edge cases, and I think that's what catches them out. But I think under normal day driving conditions, I think we are not too far off, of getting a vehicle to actually drive itself. But to do that safely, reliably, 100% of the time, I think that last 5% is what's really going to take a lot of time and a lot of effort.
In terms of technology development, we have made an incredible amount of progress in the last few years, right? Both Waymo and Cruise are currently picking up and dropping off passengers with L4 vehicles, right? And so, given that definition, there are certainly operational domains such that L3 and L2 could be better, right? Now, that doesn't mean that you can go to your dealership and buy it today, right? Consumer vehicles require automotive qualifications and retooling of factories, as well as careful work needs to be done about those operational domains, cost, and and those kinds of realistic things. But the technology has really progressed. And so I think you get into a little bit of, when would you say cell phones became a reality, right? You could certainly argue that the car phones, right, of the late 80s and early 90s fit the bill, right? But they didn't really affect everyone's lives. In the mid 90s, me and my friends, we still had pagers, right? And it wasn't until the early 2000s that you really started getting flip phones. And then the iPhone didn't come out till almost 2010. What was it? 2007, 2009, something like that. And I think we're seeing a similar thing, right? It isn't in a day. In many ways, we are meeting the qualifications even of the definition of full self-driving today, and that technology exists. But there's still a lot of work to deliver the impact of self-driving into day-to-day lives. As you look at these different products, I think you'll see different roadblocks to delivering those benefits and different approaches needed to solve them. So, like, one way to think about the state of autonomy software today is that given really good sensors, and by really good today, interpret that as expensive, right? Given very expensive sensors, we can solve what we call the perception problem. That is, looking around the car and identifying where everything is and what it is. That is largely a solved problem today. And in some applications, such as highways, that is, in fact, almost all that you need, because it's a very structured environment with very clear behavior rules. Where robotaxis are struggling right now to expand that operational domain that Pekka is talking about is more in the prediction and in the interactions or motion planning. That is, being able to answer questions like, does that person intend to cross the street, right? If I speed up, will that person slow down, right? And these are part of the difficult questions, I think, that are still being solved today from a science standpoint. So lots of engineering challenges. And from a software standpoint, from a hardware standpoint, the reality is we've got camera that's just about as good as it's going to get, right? There's some improvements. We could add thermal. We could do event cameras. There's some things we can do there. But for the most part, cameras there. Cameras are very mature tech. Radar could be improved for sure, but that's not really going to make the difference. I think that from a hardware perspective, the real key that we need in order to deliver a lot of these benefits are higher performing LiDAR, that is more points per second, longer range, more density, more control, these kinds of things, and simultaneously a lot cheaper. And that these are probably the roadblocks, right? In software, it's prediction and interactions. And in hardware, it's LiDAR, are really the things that are needed, I think, to deliver the killer apps for self-driving.
Yeah, if you look at some of the ADAS technologies today, I think automatic emergency braking is one. It's been around for a number of years. Blind spot detection, surround sensing, and then some newer technologies in terms of lane departure or traffic sign recognition, pedestrian detection. So there's been some evolution, and not all of these technologies are available in all of the cars. Some of them are only more prevalent in the consumer lower end consumer cars, whereas others are available in the high end cars as well. So.
Right, and have you seen, for example, Peter, in your for the articles that you have write and your experience from those technologies that Nathan mentioned, what are those like more prevalent now, and probably that have to do with sensing, LiDAR, etc.
Well, I think it depends very much on the level of ADAS that we're talking about. If we're talking about autonomous emergency braking, then radar is really important. There's certain suites or certain sensors that are better suited to certain functions. But
cameras I think they're probably the most pervasive of all sensors. I don't think there are any systems that really run without a camera. I think the industry consensus is that the higher levels of ADAS, moving into sort of level 3 and definitely the autonomous driving vehicles, LiDAR seems to be a given. There are some people that are saying LiDAR is a fool's destination. Mr. Musk being one of them, who's going a different path to the rest of the industry. But yes, I think cameras are given, ultrasonic sensors for close proximity, and then radar is obviously millimeter radar is almost you can't do without it either. So yeah, full sensor suite depending on what you need.
Yeah,
Right.
I think. Sorry.
Go ahead. Sorry.
I was just going to say, I think that a lot of people's first real taste, if you like, of autonomous driving would have been the sort of stop-start cruise control, and obviously the suite of technologies that have advanced since then. But I think a lot of people that have been used to that sort of level of ADAS, the future's looking quite bright, really, in terms of, as you say, with millimeter radar, etc.
To just translate that into layman's terms, right? I think exactly what Nathan said. I completely agree. Is that the state of ADAS, the state of robot assistance in cars, is that you as the human driver are still responsible, and this is kind of the defining characteristic of the current state of the art. And nothing that you're buying on the market should you trust to be responsible for your driving.
I think it's quite a big ethical question. Sorry. Just a big ethical question, isn't there, between the trust, as it were, of a human being handed over to a machine. There's a lot of people out there that, at the moment, I think it's a very difficult concept for people to understand that you could actually do that and accept. Very difficult to accept for some people.
Well, I also, sorry, Matt. I also think I fully agree with you. It's almost an ethical question. I mean, if we go back to Ford's aims or goals on self-driving, if we go back to 2017, I think it was when Fields was still CEO, Ford was planning to have a fleet of autonomous vehicles, self-driving autonomous vehicles on the road by 2020. But during their own experiments, during their own testing, not lay people, but engineers actually fell asleep behind the wheel of the car because the car was so good at driving itself. And at that point in time, Fields actually said, look, we think we're going to skip this level 3 completely. We go from level 2, which is a definite driver assist, to a level 4. We take out that intermediate because we know practically people become very trusting in the system. So whatever the fine print says, you must be prepared to take control. We're dealing with humans, and humans tend to text and drive.
You know what, Peter? You have a really good point. Like I remember, I think when we all had to do our driving test, that shoulder check, and when we were doing reverse to look at the back of the mirror. Now with this little camera that I have, I totally forgot to look back on my although the camera tells you this is not replacement for you looking behind it. And also I have these little 2 sensors that alert me if someone is walking by. And one day, I suddenly crashed because I forgot that. I was carrying something in the back of my truck, and it was blocking the sensor, I guess, and didn't detect the person. I almost crashed with someone. So that's along the line of how easy it would be to for actual drivers to deal and interact with this type of technology, and how that transition would be. Of humans actually learning that, they cannot lose those skills.
That's a very big question, isn't it? Because I think the skills, if you don't practice them, of actually being aware of your surroundings and what's going on, if you're not regularly practicing those and, you're doing a lot of, say, highway driving, etc., you soon forget. I really do think you soon forget. But, the problem of, the handover time between the autonomous and the human driver, if that's very short, then, as the speeds increase, then I think there's possibly quite a large danger present there.
Well, I see that there's a fair amount of conversation around exactly what you're talking about, Matt, where there is a point being made that maybe we should introduce a separate test when it comes to your driver's license to be able to actually engage with a level 3 vehicle. So I support what you're saying.
Yeah, I think I agree with Peter and Matt. So there should be more awareness when the driver is in the car as to what features are available, what are the limitations. So they don't tend to use a feature that's not meant for automated driving, for self-driving, and take their hands off the steering wheel. So I think that's very critical.
You're not going to have time to read the manual.
Yes.
You get into the car and you've just gotten out of a car that's got both warning and the actual braking, and you get into a car that doesn't have the warning. It's just got the braking. The two vehicles operate completely differently, but they are still ADAS, and they would still probably be, depending on what the suite is, they would still be a level 2. So from a consumer's point of view, you're going to be confused, and that's not going to be good for your confidence. What do you think, Warren?
There's this hilarious, in an abstract, right, a little bit of a hilarious dynamic going on where, the human is driving, the human is responsible for all driving behaviors. And then we realize, hey, look, humans are really bad. For example, they don't see behind themselves really well. So we try to put in a turning camera, we put in blind spot detection, we do all this stuff. And then humans learn to trust it. Of course we do. That's why it's there, right? That's what it was sold to me for. That's what I paid the extra $1,000 for. And then we say, well, humans are becoming too complacent. So now we're going to install a new system that monitors the human to make sure the human is monitoring the system that I just paid $1,000 for to maintain, right?
It's true.
And there's this problem, right, where the human and the robot are blaming each other for every last little problem, right? And the responsibility really has to be on the engineers and the product builders to educate, to build a product that is intuitive and understandable without reading a 100-page manual, right? You should be really careful about how you name it, how you market it, right? All of these things, and test it in these kinds of scenarios, right? Like the question you have to test, hey, with a new driver who's not familiar with these, right? Does this improve safety overall? And that's absolutely something that is important. It should happen. Whether or not every OEM out there is doing all of that, a lot of them are, but is up for debate.
So I think human-machine interface, HMI, is a critical part of automating the human driving process. So whether be it L2 plus or L5, and there's many forms of HMI. So I think displays are one. So it can be in the infotainment console or head-up displays. There's voice-based HMI, steering wheel, and so there's many forms to it. And of course, for the driver, they help in safety, whereas they're also very important to the passengers for entertainment and better UX.
Now, when it comes to safety, how can HMI actually improve safety in driving in the experience?
Well, I'll take that. Thanks, Edgar. As the motor car develops and we move further and further from the traditional, call it level 0, where the driver has a steering wheel and a set of pedals, and he's got his eyesight, he's got his hearing, he's got his own sensors. As we move more and more to an automated vehicle, HMI gets taken away from the driver, but the driver still needs to be engaged. He still needs to understand what's happening and more and more he needs to understand what the vehicle is actually doing, or at least have a sense that the vehicle is in actual fact doing what it's supposed to. So the human-machine interface is changing from a pure mechanical one that in the 1800s we had a tiller, didn't have a steering wheel, we had a set of pedals, and that was it. Today, that still exists, but we are moving more and more away from that, where the car is taking control and the human-machine interface is changing dramatically. I also think that the way that the vehicle actually warns the driver of either handing over the vehicle or even of an emergency situation or even a blind spot monitoring, I think that human-machine interface is going to become more and more important, and it's going to be super critical that it is accepted and it's done in a way that the driver doesn't find it intrusive and doesn't want to switch off the warning.
Yeah, I think that's a very good point, Peter. So I think also gels well with where Murata is with our piezo technologies. So haptics, I think, is very critical. So in terms of warning the driver, alerting the driver, and also in terms of, implementing into the displays as well for blind touch. So I think those are some of the areas to look into for the future. Yeah.
Doing shift in our processes based on technology. Like 100 years ago, we used to have wood in our houses, burning wood to make our food there inside the houses. Like now, that's a kind of a practice that is not common. Now we have our stove. We open the oven and there is a cold gas pipeline coming to us. But that is because we have learned to rely on very safe and secure pieces of technology that they have been proven, tested, and certified. So then the question is, based on what we have talked, how safe and reliable are those components that we use today for ADAS? And Nathan, probably you come from Murata, you have a more idea of the components. So if you could open the conversation there, that would be great.
In terms of safety standards, I mean, there are safety standards out there, like the ISO 26262, and it's just different ASIL levels. So I think we started using those. Like Murata, we play in the stability control space, so we are pretty aware of this. But it's also making its way into autonomous driving. So I think safety is pretty important. But in terms of autonomous driving, safety, to guarantee safety, you need to collect a lot of data and do a lot of testing. So I think that's it's a big challenge. You need to have big fleets and I guess many partners, and you need to have the speed and I guess GPUs to handle so much data. So I think that's one of the challenges. So what I'm seeing is in terms of safety, a lot of the players in this space are taking a redundancy approach. So they have completely redundant systems, software. So they are redundant. That's one approach to address this. Yeah.
I think
I want to point out, like, super big picture, right? I don't know worldwide statistics, but just thinking about the U.S., where I'm more familiar, automotive safety and the safety processes that we've been following have dramatically improved road safety over many decades. So much so that even though the number of road fatalities today are catastrophically large, it is smaller now. That is, fewer numbers of people die from road accidents today than did during the Model T days, right? 100 years ago, right? When the populations were smaller and there were fewer cars, more quantities of people died on the roads back then than today. And so there is this constant march of progress because these safety standards, because of this relentless push towards safety. And I do think that we're on the cusp of another large step function improvement in this. And any of those road deaths are not acceptable from an engineering standpoint. But if you zoom out really big, things are looking really good. think Peter brings up another interesting point as well, right? And that is, hey, we see robot cars as a transition point to something, and we don't exactly know where it ends up. But the question is, how does it transition, right? And there are two broad categories that people imagine. One, for the reasons that we talked about, right? How can you trust a human driver when he's asked to take over 1% of the time, right? Humans, we're just not built for that, right? We're built to try something for an hour and then trust it until it breaks. So because of things like that, there's a real strong push, I think, to say, hey, we have to, we can't incrementally slowly get there piece by piece, taking it away from the human to like 1% to 0.1% to 0.01%. But we really need to make the switch to full responsibility to the robot. I think this is one argument, right, for why L4 has to come first, or full robo cars comes first. The other, and I do think there's still a lot of merit to this path, right, is hey, can we incrementally go through ADAS? Now, maybe you could balance both of those. For example, can I buy a car? It's my personally owned vehicle, right? It can't handle everything. It's not going to go from pickup to drop off, but maybe it can handle certain highways, and it can handle those highways in a way that it is fully responsible when I'm on that highway, right? And this is a huge feature. I would love it. I would personally spend thousands of dollars every year if I could go to sleep on the highway, right? But the real limitation here is, surprisingly, and this is really surprising for self-driving generally, it's not software. The limitation here is hardware costs. The problem is that current implementations that solve this correctly and with enough reliability, right, the March of Nines, in order to switch over that responsibility, is in the 6 digits of US dollars, right, to buy the hardware kit. And so on one side, L4, I think the hard part is the software. So if you solve software, then this is the first thing to go. But boy, if you could solve the hardware problem, I think personally owned vehicles could come first, right?
There have been several, looking at it from a slightly different perspective, there have been several consumer-facing surveys asking the question from a consumer, what are you prepared to pay for these features? And I'm thinking specifically of one that was conducted by AAA, and all of them come to the same point. The consumer is not prepared to pay anything more than between $250 and $500 US for whatever it is. That is the limit of what they perceive. There doesn't seem to be a value versus cost. That is what I'm prepared to pay and no more. And I think if we're talking about the cost of technology, Warren, I think we're some way off of that, even using, the flash LiDAR, I think and cameras, I think we're way off of that still.
Yeah, these are good points. Back to the cell phone analogy, I'm reminded in 2006, I was engaged to my wife.
The same thing now. Go ahead.
But I was engaged to my wife in 2006, and my wife had never had a cell phone, but we were going to be separated and living in different states. So I absolutely 100% wanted a way to talk to her whenever I wanted to talk to her, right? So we went down to the T-Mobile store, and we looked around the phones, and I'm like, boy, $100 for a cell phone, I don't know, right? Maybe we want to get the cheaper one, right? Of course, I ended up shelling out the $100 for the more expensive one, right? But it was a few years later, and we're happy to spend $500, $1,000 on a cell phone, right? We happily drop that these days. And the reality is that cell phones started providing services that we never imagined, or at least didn't internalize emotionally, how beneficial it would be. If, for example, you could, in fact, offer someone, hey, on any U.S. highway, you can fall asleep, right? And we'll wake you up when we get to the next exit. I would imagine that a lot of customers would happily drop $1,000 for that.
Well, it depends on the front you're looking at. There's so many different areas of it. As Peter mentioned, just even from privacy and cybersecurity, all the way down to just cameras that actually capture accurately what's going on. I think they call it 4D cameras that can actually discern between a blurry blob and like that's a car and a motorcycle next to it. So, and having that kind of level all the way down to just even pedestrians as well. I know the technology varies. Obviously, you're not going to put a camera on every pedestrian, every bike, but you do need some kind of a way to beacon them so that, you know, you can identify a pedestrian from a tree. And so it's really interesting the different ways. Plus also just as you know, people talk about automated driving, you know, I think right now we kind of live in the level 0, level 1 range, which is very minimal. You know, as we all know, it goes up to level 5, which is the fully autonomous, which I think is a long way away and requires a lot more technology. But I think over the next 4 or 5 years, if we can start getting into level 3, I think that would be really good. Maybe even just like kind of a little bit of a touch on level 4. But I do like the experimentation that's going on with different cities, that they are testing it and then trying to determine which are the best solutions. As Peter mentioned, there's a big argument between you know, Wi-Fi communication and cellular and where that's going. And but I see different test cities and countries that are looking at these different technologies. And I think through that, we'll get that experience and decide what are the best directions to move forward with. Yeah, I think it's going to roll out in different facets, though. And Peter, you might have better perspective on this, but I think it's going to, like in high density areas, like a downtown Los Angeles, for instance, are going to have people movers that are going to move people around, not necessarily autonomously, but to move people around at slower speeds, no less. But they try and eliminate having any kind of vehicles at all in the very high density areas. And then I think, to follow what you're saying, Edgar, I think it's going to go. The next step is maybe like robotic people movers, where it's kind of robotics moving people around, and then eventually kind of phase into something with his own vehicle. So I think it's going to look different depending on where you are.
What type of business opportunities will V2X provide, and will this increase or decrease the vehicle demand? Which is probably a concern of many economies around the world.
Yeah, I think the demand will stay flat, but I think the vehicle ownership will change a little bit, and that'd be kind of interesting. So if you want to go to a city 4 cities away, you would go into a journey planner and kind of calculate and have some combination of public transportation and shared vehicles. I think one of the good points is that the vehicles that are out there won't be parked in front of people's houses as much or people's garages. I think they'll be out being used a little bit more effectively. So that's good, but I think it'll change the concept of vehicle ownership to vehicle sharing. So that'll be interesting. So that's why I think the demand won't necessarily change too much, but cars certainly will become more expensive because of that complexity and the intelligence in them. And that's why sharing them out will make it much more economical for everybody.
So you think that probably, I don't know, OEMs may not sell the car directly to a person like me, but I will be able to buy slots of time or a service as I go or something like that?
Right. Yeah, it'd be nice if you didn't have to own a car. Right now, most places you do have to own your vehicle to live the life you want. But I think down the road in a few years, as things develop, you won't need that. And like I said, that's mobility as a service will be a nice feature where right now we just type in, in our Uber app or whatnot, where we want to go. But it'll be similar, but it might actually be a combination of like Uber as well as sharing vehicles and public transportation. So I think overall it'll be a real win-win for everybody. And then also environmentally as well. Just a lot more effective in the communication and the transportation.
I think as we move forward and our dealerships, the franchise dealerships are going to get less and less work as vehicles become electrified, as options become less and less. So they're going to be scratching on their workshops. They're going to be scrounging to try and make up the lost revenue out of their workshop. And connectivity is an ideal opportunity. So they can start selling services. They can start selling streamed radio, streamed music, streamed video, traffic services, weather services, all as an add-on that the dealership can now start getting revenue back. So I think that's an important, somebody raised it earlier on, and I think that's an important part of the future of connectivity.
Pekka, this is a question that I've been thinking now based on what Peter and Warren mentioned. What potential business opportunities are there for OEMs then to kind of change the way it is now? Because now it's just you sell the car and that's it. How do you see the future will be on business opportunities?
There must be something new, something different. I mean, services, subscriptions could be like time-based, so that you subscribe to your level 3 for 1 month when you use more, or for, let's say, when you need for business purposes. That's the way to go. However, it's very different compared to the kind of traditional old business model, and it's not going to be easy. Tesla has been doing something there. Other ones will follow, but I mean, probably we will see different type of trials. I mean, different OEMs will try different ways to do that. They need to educate the customer. They need to educate the public that people know what they want and how they can get those features to use.
Pekka, I don't disagree with you. In fact, I probably agree with you. I'm just curious from your viewpoint, why is it that you believe that this probably has to go to some form of subscription model?
The automotive industry is so pushed with the cost, and I mean, now when the OEMs are creating the capabilities to do OTA updates, to do kind of smaller step development compared to like traditional every 3 or let's say 3-4 year steps. So that's kind of, let's say, it's a natural way to go forward in subscriptions and kind of add more features to your vehicle when it is getting more mature, if you may say so.
I see. So let me just repeat that back to you, make sure I get it. So someone's going to buy a vehicle and they're going to want it to last for 10 or 15 years. And over that 10 or 15 years, they're also going to want software updates and map updates and interface updates and all of these things. And so because you're providing benefit across those 15 years, you would expect that, and that benefit is unknown at the beginning of those 15 years, right? That some form of continuous payment maps with the continuous benefit being provided.
Exactly. And I mean, today, the development is done in kind of features. I mean, level 3 or level 2, I mean, those are kind of big things, but those are split into features. And then OEMs bring one feature at a time so that the kind of whole experience becomes more complete. And I mean, if your customer purchased the car 2 years ago, the hardware is there, did the customer already pay for that, or is for the future? I mean, it just brings the flexibility, and then also enables new business models, new kind of new applications, new ways of making money.
At the end of the day, we want to get to the point, we want to cut out that 94% of 1.2 million people that die on the roads as a result of human error. So at the end of the day, we want every single vehicle to be a level 5 fully self-driving vehicle. And at that point in time, subscription is not an option. That is the way the vehicle comes. It's got all of that built in, and that may be 30 years, it may be 40 years away. But I think ultimately that is the direction that we're going.
What about how is the government helping? Like, are the governments on board? Have you heard about regulations? Like, how is that supporting the development of ADAS, as far as you know?
Yeah, I think just some quick comments on that. So I think in EU, Japan, and China, they have some standards for L3 with some constraints. And I was recently reading that in Germany, they approved level 4 for as soon as 2022 for automatic valet parking and shuttles. So there's some regulations coming along, but I think in North America or the US, there's not been anything recently. They launched the infrastructure bill, but there's nothing relevant autonomous driving in there. Go ahead. Yeah.
Oh, please, I didn't mean to interrupt.
No, yeah, I was saying, but I think some of the states they are starting to give out some of the permits for like L4. The state of California, I think, gave out permits to some of the Waymo and Cruise cars. So that's kind of where it is.
No,
sorry.
The one clearly best thing that governments have done for self-driving in the history of self-driving, and that is the DARPA challenges, right? So the government kicked off this entire industry, right? Now, some ADAS existed before the DARPA challenge, right? But the amount of investment, the amount of creativity, the amount of energy, the amount of excitement for this technology and its ability to save lives and give accessibility and all this fun stuff was really kicked off by the DARPA challenges. And I think this is a great model for how the government can use their leverage, right, in small ways to influence technology for the better.
Well, I also think that government's influence can also be by taking a sane look at what we require and where we're going, and not being too heavy-handed in creating legislation that is restrictive, that will slow the pace down. And yes, there is always a risk that goes with it. And Nathan, you were talking about China and Japan. I believe that when it comes to the widespread rollout of level 4 and specifically level 5, I think we're going to see China being the first to actually do it. You know, we've got a population that are less risk averse, and you've got a government that can move very, very quickly. So I think they are going to be the first nation, the first region that will roll this out en masse.
Can I just say, I think that I think you're quite probably right, to be honest, Peter, but I think in the Western world at the moment, legislation is only half of the problem. I think the bigger challenge may be convincing insurance companies that they can actually cover the insurance for these vehicles. But I think that we're as consumers are really going to struggle to be able to afford perhaps the initial outlay of the insurance companies taking small steps towards, accepting the technology.
Yeah, and also may include issues for business, like even insurance companies. Like, how are they going to adjust their policies? Like, who would be responsible if there is an accident that involved an ADAS technology, the driver or the manufacturer? So,
well, what about when the accident happens at the handover point, where the vehicle says, "Well, I can't handle this situation. Now, Mr. Human Being, you need to take it over." But Mr. Human Being has got 2 seconds.
Yeah.
So he's stuck in the middle of nowhere. Who is responsible for that?
The proverbial, it wasn't me.
It wasn't me.
This would be a really fascinating conversation, I think, particularly the insurance, because it talks about who's at risk. And this will probably largely depend on exactly how it evolves, the way Peter was talking, right? If these are personally owned vehicles, then you need insurance. But if these are robo-taxi fleets, this probably looks like self-insurance, right? If you own 100,000 vehicles, right, this probably doesn't look like you buy a new insurance plan for each of them. But you can amortize that risk internally. At some point, though, this conversation gets a little laborious, just because self-driving technology alone, without a safety driver, is not yet safer than a human. And so the whole discussion about how do we convince people that it is safe is just premature, right? Well, let's not convince people of something that isn't true until it is true.
And I would like us to talk about the future. what the future of ADAS looks like and the technologies involved in it. And I want to start with a question to Matt about artificial intelligence and the role that artificial intelligence is having in ADAS. So what is your opinion there, Matthew?
Well, I think that personally, software is holding people back. I think a large part of it is the testing that can be done, because as every sort of ADAS level increases, so does the use cases surrounding it. And, artificial intelligence, whilst the promise is very great, there is a limitation. It's not, it's not magic. It's not, robots, fighting wars for us and things like that. Not yet. One of the problems that I can foresee, is at the moment we have, malware and viruses, etc. And I think that certainly for road sign detection and things like that, it is possible that this sort of thing could be used in a sort of nefarious way, and actually cause problems for manufacturers and things like that whose vehicles are out there in the consumer's hands. But having said that, every step forwards is a big step forwards at the moment. So it's a bit unclear, if the truth be told. But yeah, and these things can be fooled. We have yet to see any, malware, as it were, against the systems. There's no one's decided that they want to take things down by making road signs that aren't detectable or detectable with something else. And you only have to look online at some of the pictures of misrepresented road signs, and they look almost identical. It's a few pixels wrong in computer vision shot, and it can completely misdetect it. And I'm not sure how that could be, that problem can be solved at the moment, because it's a problem that we haven't even begun to encounter.
I'm piggybacking off of what Matt's saying about validating is really important. It's surprisingly difficult. Modern artificial intelligence suffers from bad branding. It is not very intelligent. If I were to name it, I would name it something more like artificial pattern matching, right? And this means two things for the data testing side. One is that, I'll give you an example. When I want to teach my daughter how to cross the road, I walk her to the crosswalk and I say red means stop, green means go, and then we're just done, right? She gets it for the rest of her life. When I do this with artificial intelligence, I have to give it a million examples of what a green light looks like, what a red light looks like, and it may still run into a red or green light that it hasn't seen before and be confused. So because it's just pattern matching, right? It's just matching to what it's seen before.
Absolutely. The amount of data involved. Sorry, Warren.
No, you're right. You're right. Yeah, this is great. And the other side that Matt is pointing out is absolutely correct as well, and that is, even though it's really inefficient at learning, because it is learning, that means that at some level we don't fully grasp its behavior in all scenarios. And this means that it has to be validated statistically, right? And validating something statistically, especially with lots of nines on it, right, requires an incredible amount of data, right? Depending on what assumptions you're using, right? This is certainly in the millions of miles, right? You could put in reasonable assumptions that say billions of miles, right, are necessary for appropriate testing. And so there's a lot of innovation that has to happen between collecting those miles. How do we use simulation appropriately, right? How do we use the right statistical or actuarial approaches, right, to ensure that we're both allowing the technology to be released in a timely way so that it can save lives and buy back our time, but also also not so premature, right, that it has the exact opposite intended consequence.
I think that you touched upon something that at the moment I see as a bit of a problem, which is updating the HMI, and not necessarily just software, but hardware, because when we have things like cell phones, etc., which develop very quickly, very short cycle times. They make a car look dated, in a couple of years maximum, really.
Well, it's exactly what I was going to say. I mean,
okay.
a car runs on an 8-year life cycle, and a cell phone runs on a 2-year life cycle. The updates happen, the hardware updates happen so rapidly in consumer electronics, and I think we're almost getting to the point where the car becomes a consumer product, and people are expecting that same level of update as regularly. That must be challenging within.
Yes, that is challenging. So I think for the cars, definitely you have to hit the reliability and the longevity. So I mean, today we're looking at sensors or hardware that operate over a span of over 16 years. So and that's kind of the life cycle we're looking at. But I know a lot of the new players, the EV market, are looking at more a cell phone based or a change of hardware. I mean, that doesn't happen that fast in automotive. So there's other factors.
Now you bring a good point here with the technologies that enable and help with the HMIs. What about those new technologies, the telecommunication technologies like 5G or even 6G that already started to be developed? How do you think, and Nathan, that they will impact HMIs?
Yeah, I think new technology, I mean, it's definitely good to have improved connectivity within the car if you're doing cloud-based processing. So, for example, for voice-based systems, if there's cloud interaction, then I think improved connectivity helps there. And also, I think I was reading recently, there was also like exterior HMI, right? So where the car communicates with a pedestrian or bicyclist and warns them that they're approaching in their path, or stops and lets them know that you're good to cross in front. So,
talking about that HMI, there are a number of companies that are looking at light and sound. And one of the trials that have been run, once again by Ford, is using a series of 5 lights that are sequenced between stationary and flashing, and 3 colors to warn pedestrians that a driverless autonomous vehicle has either recognized them, has not seen the pedestrian, is accelerating, slowing down, or preparing to stop. So that is a human-machine interface, as Nathan says, externally. Okay, but I think HMI is going to shift from driver experience to user experience as vehicles become more autonomous and driver engagement becomes less important with the vehicle. Infotainment is going to become more important for driver as well as passengers.
I would completely agree with Peter there, 100%. But may also add that I think there is a lot of scope for personalization as well, a huge amount of scope. And I think that could be make or break depending on the vehicle and the customer.
Yeah, I think from my perspective, I think there'll be significant opportunity, at least for us, in haptics, be it for driver monitoring, driver engagement, or maybe also head-up display in terms of the growth there. So I think that's where I see some of the new improvements happening. And also, one area we didn't touch earlier was in terms of gesture. So that's also another way of controlling.
Yeah, so predictions in this market are notoriously bad, right? So I'm not going to make one, but what I will say is that we have a choice in how we allocate our resources, right? We can, and we live in a world right now where perception and AI is way better than we should have expected in 2015, right? The progress we made there on the perception side is enormous, right?
Right.
And so you see some players, for example, okay, well, it turns out motion planning is harder than we thought, right? So let's go do highways where perception is harder, but motion planning is easier, right?
Right.
And there's the software and the hardware components, right, which really will determine a path forward. I don't know exactly which path is going to go forward, which one will win out, but it's going to be a real fun thing to watch. And whichever way it goes will be a benefit to all of us.
Thank you. What about you, Matthew?
I think it really depends on the amount of processing power that we can get into component, or the control systems. That's the real key, I think, at the moment, as well as acceptance by insurance companies and the consumer. And at the moment, it really is a crossroads. I think it could go very much one of two ways: either nobody accepts it, and things move slowly, or I think Peter said somewhere like China makes a big leap forwards, and all of a sudden, we're talking about old news, and everyone's doing it.
Right. Okay, that's good. Let's see what happened. Nathan, what about you?
Yeah, I think if you look at the overall interest for ADAS and looking ahead, so I think consumers see value in ADAS features, and I think EV manufacturers have accelerated the trend. There's high interest in highway hands-free driving, for example, but I think cost is still to hold up with some of the sensors that we have. But then I think I expect to see increase in L2 usage and then L3 from 2023 and then L4 after 25. So that's kind of what I think.
Yeah. Perfect. Thank you. And Peter?
Okay. Well, I think it's a partnership. I think I believe the end goal is going to be fully self-driving autonomous vehicles. I'm not going to hazard a guess, but the partnership is going to be it's going to be a push-pull between regulation, the technology of the maturity of the technology, and thirdly, the will of the customer to actually accept it and engage it and buy the vehicles.
Well, thank you. Now, there is one very interesting question that just came, and it has to deal with the ADAS stagnation. Like how easy or difficult would be for previous ADAS to be upgraded to a higher version of ADAS. So I think Nathan and Peter, if you can help us on that question.
Yeah. Go ahead, Peter. You want to take that first? Or?
Okay. Well, I think as costs come down, sensor costs come down, I think a lot of vehicles, we'll see more and more vehicles actually leaving the end of the production line with a sensor suite already built in, with over-the-air updates possible. And I think it'll just be a software update to bring it up to the next level, which also ties in a bit to what our earlier discussion was around artificial intelligence, about coding. So I think the vehicles will leave and they will be updatable to a point. So whether you're ever going to be able to take a level 1 vehicle to a level 3 or a level 3 vehicle to a level 5, there may be some hardware or firmware updates that might be required to take it there, but generally I think they will be able to.
Yeah, Nathan? I think I agree with Peter. So I think if you're looking at level 2 plus, so the hardware comes built into the cars, and then its software is updated over the air to turn on certain features. But then, of course, if you go higher up in the levels in autonomy, then I guess you need to add more hardware or sensing on the vehicle.
I believe goes to you, Peter. It says V2X cars will create tens of terabytes of data in a single day. How will it be possible to analyze that data, and where will the data be stored?
I think, like with most connectivity and automated solutions, it will depend on whether the system is a safety critical system that requires very low latency, or whether it's a general information type processing. So I think in automated driving, a lot of the processing will actually be done on board through either smart sensors or through sensor fusion, and thereafter edge computing for the remainder, for functions that can't be done on board. And then I think your general computation will happen in the cloud through the Internet of Things, and that will be basically information and data crunching.
Yeah, I see the government's owning quite a bit of the data because it's on the infrastructure. Wouldn't you agree? I mean, if as you're driving down public roads, the government's going to kind of see who's doing what. But then, like you said, in the vehicle, I think it'll be owned by whoever owns the vehicle. So it's going to be interesting.
As we said, there's a long way to go.
And we have a last question that, it's partly technical, I think partly philosophical, so I don't know whoever of you want to answer it. It says, some consumers are wary that automated driving is as trustworthy or moral as a human driver. Are there any technology developments that could ease their concerns?
Yeah, so this is a fun one. Let me put on my philosopher hat. It's really tiny. I'm an engineer. But if I put on my philosopher hat, I would submit that robots don't have values or morals in the same way that you or I do. So I'm going to have to try to guess a little at what the questioner is asking. And here's an example of what I think the questioner is asking. Years ago, we bought our first Roomba, right? So here's one of the first robots that can move around and interact with the environment in my home. And we have a problem. Our problem is that we have a dog who's like 99.9% potty trained, right? But that 0.1%, boy, we were not going to let that Roomba run when we were not in the house, because you just Google poop and Roomba and it's just catastrophic, right? So now it isn't that Roomba has different morals or values than me, right? But when it behaved that way, or if it were to behave that way, right, I would feel, it would feel personal, right? I would feel like it was an affront that this robot clearly feels differently about spreading poop all over my floor than I do, right? Now, it is doing no such thing. It is purely following instructions. And so I believe that, it doesn't have morals, it doesn't have values. It has inputs and it has behaviors. And those we give it. And we absolutely 100% have to make sure that these cars don't drag poop all over your carpet. Or it's just not trustworthy, right? It's a different kind of sense of trustworthy. It isn't the same as, I go to the store or I make a deal and I look someone in the eyes and I shake their hand and I decide I can trust this person, right? It's not that kind of trust. It's the kind of trust that I can turn my toaster on and it's not going to burn down my house,